Hi everyone, this is Ashok. My project COT6405 analysis of algorithm is algorithm analysis for the majority element problem. In this problem, the first of all we need to get to know the problem definition. This problem we are going to evaluate the three algorithms: brute force, divide and conquer, and Boas-Morris algorithm. This is the linear one, Boas-Morris algorithm. Uh, the problem statement defines that the problem is to find the majority elements in an array. The elements that appear more than n by 2 times in the array, where n is the length of the array. The algorithm an array of integers. The object is to output the majority element and its average runtime for each input array. Here we are going to take the input size of the length array and denoted by the n. The algorithm is tested on the array on various sizes, ranges from 1000 to 10,000 integers. These are implemented in the Visual Studio Code, which I am going to show you right now. This is the code for the each and every algorithm. Brute force, this is the algorithm, and brute force, this is the linear one. This is the brute force, and this is the divide and conquer. This is the file which it will generate the input file. As I say you, as in the input file, it varies from 10 power 3 to the 10 power 10 times. The sizes vary from. In this case, we are going to find the majority element in the array. This is how I am going to run this generate.py file. Let's see the output. If you see here, an input file text.generate generated. Here we are going to find the input text.find is the random generated. Now we are going to run the code using the different algorithms, BN algorithm. Here we got the output. If you see the output, the majority element, and it is the output generated, and I have got a graph. Here if you see in the code, here you see this is the code. Here is the start time and the time. Here is we use this one, and here we use the label, and the graph is generated. I can show you. The graph is generated. I can show you. I put in the report. If you go here and if you check, this is the generated one. This is the Boas-Morris algorithm. Here it varies the graph from point. Here it goes as I take a value from 10 power 3 to 10 power 3, 10 into 10 power 3. These the ratios, and these the constant values I got. SRT analysis. This is the output I got from the following code, which after running here, it's gonna take some time. So I already done it, and I explaining it in clear. So in the similar way, the brute force and the divide and conquer also I have implemented using the generated.py input file by generating the input file. So at last, here we see this is the pseudocode. This is the pseudocode for the algorithms, and I have implemented in Python programming, as you can see in the code. This is the input generation and the resultant graph as the values and the ratios as RT I have implemented. This is the output of a graph. This is the predicted RT, and this is the empirical runtime. Here you can see the runtime versus the length of a string for each and every algorithm. This is the Boas-Morris algorithm. It's the linear one. Its complexity is big O of n. And at last, we can conclude that the theoretical as the brute force performance for the worst and the taking the most time for the larger input sizes, whereas overall the Boyce-Moore algorithm is the best algorithm solving the majority element problem in the terms of runtime. The brute force algorithm should be avoided for larger input sizes, while divide and conquer can be used for the alternative in Boyer-Moore algorithm is not applicable. So this is the how write the code and generate the output. Yeah, that's it. Thank you.